So we know that the examination of aerobic metabolism or oxidation of glucose is good introduction to oxidative phosphorylation and gives a consistent basic of comparison to anaerobic lactic acid as they have the same starting point. And then kalau kita kata what about the other metabolism of other nutrients? For example, carbohydrates, protein, and fats, macam mana dia metabolized for the energy? Okay, first thing first is that remember that the first step in the process is the preparation of the compound for the aerobic metabolism. Once the acetyl-CoA is formed, the step of the Krebs cycle and the electron transport chain are the same regardless lah whether the original source was carbohydrate, protein ke, fat or fat. Carbohydrates, protein and fat dan kita akan tengoklah in detail in the individual chapter. So macam mana kalau kita tengok fats kalau dia metabolized aerobically by the oxidation of fatty acid. Metabolism fat ni dia very complex and also kita kata varied. Okay, but the principal fat metabolized for energy in the body are fatty acid. They containing chain of either 6 or 18 carbon. Contoh kalau kita ambil palmitate ataupun stearate respectively. This fatty acid chain kita as we know that is stored as a triglyceride in fat cells ataupun kita panggil dalam lipocytes and in other tissues such as muscle. A triglyceride is composed of a glycerol molecule dengan apa? Dengan 3 fatty acid chain attached. So when fat is needed for energy, kita ingat balik triglycerides akan broken down and the fatty acid chain are transported into mitochondria for the aerobic metabolism, and the lipolysis is the term used for the breakdown of the triglycerides. And if you can still remember, when fats are to be metabolized, they must first be mobilized from the adipocyte. Lipolysis occurs breaking the triglyceride down into the glycerol and the 3 fatty acid. The fatty acid are then released from the adipocyte into the blood for the transportation throughout the body. At this point, they are usually referred to as what we call as a free fatty acid. This term is a bit of a misnomer as fatty acid must be bound to a protein in order to be carried out in the blood. So albumin is the most common plasma protein that binds free fatty acid in the circulation. As free fatty acids are distributed throughout our body, they are taken up by various tissues such as muscle and after an activation step that requires the use of ATP, the fatty acids are transported into the mitochondria for the aerobic metabolism. So before they entering the Krebs cycle, however, the fatty acid must pass through another series of reaction called what we call as a beta oxidation, which is this beta oxidation is a process that comprising 4 chemical steps that occur in the mitochondria matrix. The overall function of beta oxygen is to remove 2 carbon segments from the fatty acid chain and convert them to acetyl-CoA. So again, once the acetyl-CoA molecules have been formed, they can enter the Krebs cycle and be oxidized. The process of beta oxidation also results in FAD and also NAD picking up electron, which can be used in the electron transport chain. So 8 2 carbon segments can be cleaved from a 16 carbon fatty acids such as palmitate, one of which is acetyl-CoA. 7 of each go through the series of chemical steps to form acetyl-CoA. Compared to the 36 ATP produced from the aerobic metabolism of glucose, the complete metabolism of the fatty acid palmitate results in about 129 ATP. Okay, so actually you have learned about this in the your punya biochem class lah. Okay. So the clear advantage of fat metabolism is the large of ATP, 129 compared to kalau glucose tadi 36 ATP saja. Tapi kalau untuk fat ni dia akan hasilkan about 129 ATP. In addition, even a person with a relatively low percentage of body fat has a large number of kilocalories stored as fatty acid in adipocytes, which are accessible for metabolism. The disadvantage of fat metabolism include the increased number of steps required and number of oxygen needed for aerobic metabolism. This will increase the oxygen requirement that will be discussed after this. Okay, to number one. Okay, kalau kita fat. Okay, when we look at in terms of protein pula, okay, protein is not stored as energy source in the same sense as carbohydrate as glycogen and fats as triglyceride predominantly in adipose tissue. The proteins are typically incorporated into functional, for example, enzyme or structural, for example, skeletal muscle, elements in the body. Many proteins can, however, be broken down into their amino acid building blocks under certain metabolic conditions. Amino acid can be metabolized aerobically once the amino ataupun nitrogen containing group has been removed. The nitrogen group are typically removed by either being transferred to another compound ataupun kita panggil sebagai transamination ataupun being removed completely atau kita panggil sebagai deamination. This nitrogen is eliminated from the body as urea in our urine, in our urine. So protein metabolism is complex, okay, because there are 20 amino acid as we learn, and there are variety of points of entry into the oxidative process. Sebagai contoh, alanine dan isoleucine are amino acids that are readily oxidized and are given as example because each has a slightly different way of being metabolized. Contoh alanine. Alanine adalah 3 carbon amino acid which when deaminated can be converted into a single pyruvate. The pyruvate can be oxidized via Krebs cycle as previously described. Isoleucine, one of the branch chain amino acid that contains 6 carbon. So each 2 carbon fragment can be converted into acetyl-CoA, which can then be oxidized in the Krebs cycle. 3 acetyl-CoA can be formed from each isoleucine given the 3 turns of the Krebs cycle, dan dia akan menghasilkan lebih banyak ATP lah rather than the alanine just now. So the branch chain amino acid macam leucine, isoleucine and valine can be relatively easily metabolized by the skeletal muscle. Okay. Of the 3 energy containing nutrients, protein is the least preferred as a fuel of source, and it is the least preferred as the fuel source. Because although amino acid can certainly be metabolized, they are not stored for ready access as a carbohydrate and also fat. Okay, along with additional steps required to remove and dispose of that nitrogen group too, this limitation prevents protein from making up a large portion of the fuel source for metabolism, particularly during exercise. So under metabolically stressful conditions such as starvation ataupun exercise in a glycogen depleted state, for example, later stage of marathon, protein may compose a larger percentage of the fuel utilization, but rarely exceed 10% of the total energy production. In terms of how to utilize carbohydrate, fat as a fuel, sebenarnya kan carbohydrate, protein and fat can be used as fuel sources both during rest ataupun during exercise. But which fuel source is used and under what circumstances? Maknanya bila nak digunakan protein, fat or carbohydrate, and how is the source of the fuel used for aerobic metabolism determined? Okay, although 3 fuel sources are available, okay, protein is used only to a small degree under normal circumstances. The preferred fuel sources, of course, number 1 is carbohydrates and also number 2 is fats. Which fuel source predominance is largely dependent on open activity level and exercise intensity, and can be modified by diet, activity duration, fitness level, or exercise training status and other factors. At rest, okay, the preferred fuel is source is fat. Okay, waktu rehat at rest, the preferred fuel source is fat. As I mentioned earlier just now, even a person with a relatively low percentage of body fat has ample fat stores, and fat oxidation has a very high ATP yield. Because the rate of energy expenditure at rest is low and there is no need to replace ATP quickly, there is sufficient time for lipolysis, fat mobilization, and also beta oxidation. Even though fat oxidation require additional oxygen consumption, there is sufficient time at rest for the pulmonary and also for the cardiovascular system to supply all of the oxygen that is needed by our body. The body doesn't rely 100% on fat oxidation at rest. However, some tissues such as brain cells, they rely on carbohydrates, as we know, as their primary source of fuel. In addition, excessive reliance on fat metabolism results in the production of keto acid. When produce is excess, keto acid can disturb the acid balance in the body. Example of this can be seen in those who have difficulty metabolizing carbohydrates. People with diabetes, for example, can be susceptible to diabetic ketoacidosis if their diabetes is not managed well and they rely too extensively on fat metabolism. Under normal circumstances pula, at rest, fat is generally the predominant fuel source, making up approximately 85% of energy expenditure. Whereas carbohydrate make up the balance, which is about 15%. As activity increase, the body begins to rely more on carbohydrate and less on fat as a percentage of total energy expenditure. As exercise intensity increase, the percentage of kilocalorie derived from fat metabolism decreases, and the percentage from carbohydrate oxidation increases. At fairly modest level of physical activity exercise, such as walking at a moderate pace, the mixture of fuel is about 50% from fats and 50% from carbohydrate. As intensity increases above the modest level, then we know that carbohydrate becomes the predominant food source. At moderate to hard exercise intensity, for example, kalau distance runner race pace during like a 10 km marathon, nearly all the energy expenditure is derived from carbohydrates. There are fewer chemical steps involved in carbohydrate oxidation and less oxygen consumption is required for the amount of ATP produced, making carbohydrates the preferred fuel source at a higher intensity exercise. So the distribution of fat and carbohydrate metabolism can be modified to a certain degree by other factors such as diet. The distribution of fat and carbohydrate, the chronic consumption that is over a period of days or week of a high carbohydrate diet influence the body to rely more heavily on carbohydrate metabolism to a certain degree even at rest. When the athlete consumes a high carbohydrate meal before exercise can also influence the body to rely slightly more on carbohydrate at the same exercise intensity compared to not eating or fasting before exercise. Similarly, chronic consumption of a high-fat diet influences the body to rely more on fat oxidation at rest and during low and moderate intensity exercise. Higher intensity exercise, however, still rely predominantly on carbohydrate. So, fuel utilization may change somewhat over the course of a single exercise bout, even if the exercise is performed at the same intensity. At the onset of a moderate intensity exercise session, for example jogging, carbohydrate may provide the majority of the energy. Given the step involved in fat oxidation, there is lipolysis, mobilization, beta oxidation, there may be a lag time between the onset of exercise and when fat metabolism reaches its peak. There is often a 10 to 20 minute period of time at the beginning of exercise when carbohydrate metabolism takes precedence until fat oxidation can catch up. Duration can also affect the fuel utilized in moderate to higher exercise intensity if the exercise continues for a long period of time.